start again. My name is Nevena AKSIĆ and I'm a student at the University of Kragujevac at Faculty of Engineering Science. These days, usual topics when we are talking about refrigerants are F-gases and new F-gases regulation that came up at 1st January on 2050, so what's going on? So here is what today I will talking about, that's FREON gases and how we can put them in control so we can use them in new F-gases regulation. So today I'll talk about, well, let's start a brief history of refrigerants so we know what we are talking about. Then we can see what's the problem and how we can define him. Also, what is existing units, what we are dealing with. And after that, what is that reconstruction? One new thing, which is innovating thing, how we can deal with it, because we cannot do that just with reconstruction. And after that, is that useful? Is there any benefits because we are doing that? So let's start. I won't bother a lot with the brief history because we all know what refrigerants are and how they are in this cycle. So I just mentioned two things. We can see natural refrigerants and we can see F-gases, different one, but they are all F-gases. Two important things, technical issues and environment safety. That's because we need that for our future problem that needs to be defined. Also, one interesting thing we can see, it's a circle. So, will it stop somewhere? We don't know. The lots of investment is in research for F-gases, but also in natural refrigerants. So, where it will stop, we don't know, but we know what's the problem. So, let's see how we can define it. First, we have new F-gases regulation, which means we need to have measurable systems under control, that is environment safety. What does it mean? We invest big amount of money in systems, in retail markets, in supermarkets, in food industry for our refrigerants, and then what? We have new regulations, they are working on F-gases, they are not suitable, so we need to invest more money in what? In the installation of existing unit and then installation in new one. And also we have new technologies as CO2 or ammonia, and there is another problem that is more expensive than now units we can buy. So is that a local thing? Is that expensive just in Serbia? No. These are big investments, so they are expensive everywhere. So how we can deal with that? There is one solution. Can we make existing units usable in new regulations so we can work with that? So I think this work will show that we can. How? So first let's see what we are dealing with right now. This is a simplified schematic picture where we can see every usual parts in one refrigerant system, which is compressor, air cooler, expansion valve, and also evaporator. Usual things, F-gases are circling, we all know this stuff, but what can be changed? Simple change. What we can make is that change our evaporator, air condenser to water-cooled condenser, then to use heat exchanger. After that, we can use, here we have water tank, that's a mixture of water and glycol, and then we have water cooler, we don't have evaporator, classical evaporator with Freon. Why we need this reconstruction, what this reconstruction showed to us? At this point, nothing, it's kind of investment, we need to change something, but this is innovative thing in this work. So the first thing we can see is hermetically closed vacuum environment. How? Well, we all know what is ultra-low oxygen air cooling, right? So we have hermetically closed units with panels, sandwich panels we can use, and then we have some manometers or vacuumeters where can we measure low pressure. So we'll see why. Also we have F-gases detectors, vacuum pump, F-gases recuperator, and PLC. So how these innovative things work? If there's any air flow in this box or a room, because we cannot guarantee it's totally hermetically closed, right? Then our manometers measure the higher pressure in the environment, so it sends the signal to our PLC and then to vacuum pump. And is that totally secure? No, but we have one more F-gas detector inside the vacuum pump in the pipe. So if there is a small amount of freon even there, our F-gas detector will send signal to PLC and pump won't work, so we have freon control. First thing with new F-gases regulation. What is the next? If we have big amount of freon in a room, then our other F-gases detectors will detect them, so then the signal is sent to PLC. And also it's approved by manometers. Now our F-gases recuperators start working and we have our F-gases controlled and measurable in F-gases cylinders. So what we can do with it now? We can reuse it if it's the F-gas like F44A, or we can recycle it. And all this now have more sense. If we have a reconstructed system, why? Because then we can put this innovative room or box, depends on the size of our unit, and then what we can see. We have F-gas piping system which can be long for a kilometer, so how we can detect small leakage, and it's banned because of the potential of leakage. On this system we can control it totally. And after that, the thing that can go in the environment is mixture of water and glycol. And does we need to do this? Is this important thing? So, yeah, if we have some benefits. Well, let's start with the technical benefits we have here. First, we have a cooling capacity benefits. We can see here, when we are cooling F-gases, the condensing temperature is 40 degrees. After that, if we change and reconstruct our system, our temperature of water, condensing temperature, is 25. As we can see on this simple table, we got benefit in cooling capacity. That's one thing, but this is something we need to have in market. So also we need to have something that we call cost value proposition. Does our customers need this, or they can invest more money? Should they risk? So here we can see that they should risk. They should do something like this, because if we use an average cold storage, cold unit we used here, which is from 200 to 300 tons of product in plus regime, so we can see here that the economical savings are about 37%, rather than investing in any other unit, which means installing new one, installing new that are working with new F-gases or ammonia or CO2. Also, F-gases have a sudden leakage potential, so we need not just to invest once, we need to invest all the times there is mechanical damages or just damages that Freon itself make. When we are controlling it, when we have possibility to reuse it or to recycle it, we can make savings more than 85%. Well, it can be impressive, but new F-gas regulation says one more thing. It must be environmental safety. So here is a climate benefit we can make. As we all know, 90% of existing ozone holes are made by F-gases. They are phased out, but we can still find them in old buildings. So controlling them, we can reuse it to less than 5%. And new F-gases regulation is because of the global warming. Shown in CO2, we can see how much we can reuse per refrigerant unit in the same sizing as we are used to calculate all the other benefits. And what is all about this? Why we need this work? What should it show? It should show that this kind of reconstruction and innovative technology can be applied by new F-gases regulation, can have more benefits than just the technical, than just environmental. It can have great potential on market with real customers, with real investments because of their economical savings. Thank you very much for your attention.
Thank you. Dozvolite mi da vam se još jednom zahvalim na učešću u ovoj studentskoj sesiji. Da ponovim još jednom na kraju ove sesije da vam stojimo na raspolaganju kako tokom procesa završetka vaših studija, tako i u prvim godinama vaše profesionalne karijere, a kao što vidite i ono što vas posle toga čeka u ovoj oblasti. Zahvaljujem još jednom. Posle ovoga imamo obilazak izložbe i osveženje u restoranu. Hvala lepo. Prijatno. Do sljedećeg kongresa. Prijatno.